So I've been extremely fortunate that the astronomical community, especially the Pixinsight community, have been so supportive of my efforts to make videos like this, for example, on WBPP. One of the things that I asked out there is that people give me different data sets that require different configurations in WBPP so that I can demonstrate how to set them up properly. And this particular example comes from a kind gentleman, James Madison, who provided his one-shot color camera data. Now, this is a cooled camera of the Lagoon Nebula. So these are color images, color-in-one images that I'll be processing here. And if we look at the folders, if we look at his directories, we can see what he gave me, which is the light frame data for the Lagoon Nebula. We have flats. We have darks that'll calibrate the light frames. And then we have, and I'm going to be very careful about the word I use here, we have dark frames for flats, which are often called flat darks. And we can use those to calibrate our flat field images. I'll explain why I was so careful about that in just a moment, because of the philosophy that I use to approach, whenever I have a data set, how do I approach beginning to configure WBPP. For example, let's actually do the following. Let's look at the data itself. Here you can see that this data, these one-shot color camera data, were taken across multiple nights. So he has multiple nights of data. If we go in, we can look at the files, and we can look at one of them and see how the data looks like. That's wonderful. Look at that. It's the Lagoon Nebula. Looks fantastic. If we zoom in, we can see that this is it has not been debayered. So it has yet to be debayered to make it a color image, but the Bayer matrix is still in place. If it wasn't in place and he was giving me data that he thought was raw, I would say, no, something has happened to this data, but that's not the case. This looks perfectly normal. Now, one of the things that I do, and again, this is the philosophy, I look at the data before ever loading it into WBPP because it can avoid all kinds of problems and frustration. So this is what I teach in FastTrack Training, and I hope to demonstrate right now why it is so important. I happen to know something about this data because I looked at it before. One of the things I know is that, and this is what I always check, I always go look at the FITS header and see what the information about the data is. One of the things that is not in this list, I see all the normal stuff, exposure time, I can see the camera that was used, and the fact that it is this ASI camera kind of tells me it makes sense that he was using, he had to create dark frames to calibrate his flat field images. So that makes sense. It's that kind of sensor. I can see it is a cooled camera rather. But what I don't see here is the pattern for the Bayer matrix. It's not listed here in the FITS header. And so one of the things that we need to set up, as I pointed out in the tour, is you need to tell WBPP what pattern the one-shot color camera data is. If you don't have that information there and it's set to auto, it's going to fail because it's not going to find the information in the FITS header. Let me demonstrate that to you. If we go here to debayer, there it is, and I ask it to debayer in the auto sense, this is the way WBPP is set up kind of initially, it's not going to work. And it says it's unable to acquire the CFA pattern information. The required image metadata is not available. That means it's not written in the FITS header. So what do we need to do? We can discover what the pattern is, although we can take a very good guess. Most of the time, like 90% of the time, the pattern is the first one here, RGGB. So let's see if that's true. We know what color the Lagoon Nebula is. And indeed, the Lagoon Nebula is red or reddish or something. This must be the correct color. Now, it doesn't look right. I mean, it looks too green or something. And that's because it has yet to be color corrected. But for a raw image that has just been debayered, this must be the correct answer. So we know it's RGGB, and that's what we'll program into WBPP at that point. We should, in the same breath, go ahead and look at some of the other data here and just make sure that it all makes sense. So we'll look at the flat field images. Let's just look at a flat. For the flats, we expect there to be a certain amount of light. There is some light here. I suspect that this is not a 16-bit camera, so I see a value that is lower than 0.5, but it's fine. There's plenty of light. I can see the vignetting towards the edges. That makes sense. And I can see that this has not yet been debayered. So that makes sense. Let's look at the dark frames. We have two kinds of dark frames. We have a long dark frame here, and then we also have a short dark frame here. And this is a dark frame that's used again to calibrate the flat field images. What I'm expecting to see is a slight difference between the two. I would expect that, yes, here, when we look at the longer dark frame, do you see that there are more of these hot pixels showing up? I don't see nearly as many hot pixels here in the short exposure. So that is always indicative of a longer exposure. I doubt, for many of these cameras these days, the CMOS cameras, that you're going to see a huge difference in the number because the dark current is so low between these sensors. I mean, I see, about 0.4 or a little bit less for some values here. Maybe this has a little more on average. It's hard to say. So the values themselves are either equal to one another, or maybe, the longer exposure is slightly elevated in its values due to some kind of dark current. But other than that, everything makes sense. I still want to check, though. I always check the FITS header. Let's just look and make sure that things make sense. I can see that the image type is a dark frame. That's good. I can see the exposure time and I can see the temperature. So everything kind of makes sense to me there. Let's do the same thing for this dark frame. This is a dark frame that's a short exposure used to calibrate the flat field images. Because when we looked at the flats, they have the same exposure time, 0.44 seconds. So if I do a track here, now I'm seeing the FITS header of this file. And if we look at the image type, we have an issue. The image type here should read dark frame, but it reads flat field. And that, unfortunately, is going to wreak havoc when we load this into WBPP. This is an error. Now, this happened because when these images were created, there's probably a selection, and I don't know how it works in Sequence Generator Pro, but there must be a selection where you indicate the type of file that you are creating or taking, or maybe there's actually an error in the program, because I can see it says dark flat here for object name, but it labeled them as a flat instead of a dark frame. And when we load it in WBPP, that's going to be an issue, because it's going to put it in the wrong panel, basically. And I think one of the sources of confusion is that this statement here, dark flat, when you write it like this, it seems like the dark is the adjective for the noun flat, meaning this has something to do with a flat field image. In a way it does, but the way that you would actually read this is a dark frame for calibrating a flat field image. Darks for flats is the way this really should be read. And another way to write it is, of course, a flat dark. In that way, you say the flat is the adjective for the noun dark, and then maybe there isn't as much confusion? I don't know. But this is a case where that confusion obviously happened at some point, and it will only cause frustration for people who are unaware of why it loads incorrectly. So I'm going to demonstrate not only that it loads incorrectly, but of course how to easily fix it. And this philosophy that I just demonstrated, what I just showed you, is the way that I approach images all the time, and it's what I teach in FastTrack Training, that is my course for beginners. And then I claim that once people see that and they understand what to look for, that will minimize all kinds of problems and frustration in using Pixinsight in general, and of course the script, WBPP specifically. So, WBPP is what we're going to get out. Now that we have WBPP up, I will first use the easy button. I mean, this is the button that everyone wants to use, right? Because it just loads everything. So I need to, of course, navigate to the right place. Hang on. Here we are. This is the correct directory, and it'll load all of the files underneath of here. So let's do that. Okay, it loaded files. I don't see anything strange that it didn't understand what it was, so that's good. And we should be able to see a number of things loaded here. One thing that I don't see, which is kind of part of the issue, is I don't see two things in the darks. I only see one set of darks here, right? That's a hint that there should be a problem here because we had two folders for dark frames. We had the long exposures and the short exposure darks. This is going to demonstrate that here we only have the 300-second darks loaded here. And if we look in the flats, we have 0.44 seconds, but we have the ones that are labeled flats, and then we also have these things here that are called dark flats. That's the problem. So I can either fix it, or what I can show you is the way that I would have loaded it as a beginner, as I teach in FastTrack Training, that does actually avoid the problem. So let me show you, without me having to manipulate any files or anything like that, if I instead clear everything and we just reload this, but not with the directory button. So I'm going to specifically load each of the file types. We don't have biases. Each of the file types by hand. So if I load, these are dark frames. So when I use the button load as darks, I am forcing them to go into the darks bin. So they're no longer called flat field images. Now they are dark frames. I am using my brain to say where files go, regardless of what was written in the FITS header. And in that sense, if a person does this who may have data that's of some weird way, then you avoid the problem entirely. The same thing is true. All I do is I open up this again and load the other dark frames, and now I will have two different kinds of darks within my darks panel. Then of course I can just load the rest of these things. Here are the flat field images like this, and then I load the lights, which are in this directory here. Now, unfortunately, if I'm going to load them individually, then I need to, let me just go into each one of these. I wonder if I could use the directory. I'm not going to do anything fancy this time. But this assures, absolutely 100% assures, that when I'm loading this data, the only way that there can be a mistake in the loading of the data is if I, with my brain, made it. You don't get to blame WBPP for not doing it correctly. WBPP, when I first loaded it with the directory button, was doing everything correctly. It's just that the information that it was working with was not correct, and that's what caused the problem. So now I have darks, two kinds, flats, and light frames. This time when I look in the calibration panel, things are going to look much, much better. So if we look closely, we can see that these flats, the status is that they are going to be calibrated with a dark frame. And which one? Well, we come up to the darks groups here, and we can see that they will be calibrated with the set of dark frames that have the same short exposure. That's exactly what we want to have happen. And likewise, when we click on the light frames here, we can see that they are calibrated with both a flat and a dark. Of course, there's only one flat, so it matches that. And it'll be calibrated by this dark frame right here. That is also shown if we look at the calibration diagram. We can see that it's reflected that once it creates the master dark and the master flat, that they will be applied against this original raw light, and it'll be calibrated accordingly. Same thing is true if we look at the flats here and we look at this calibration diagram. We can see that it's using, which was not true before, and it would have caused us a problem, because it would have tried to calibrate with an exposure time that was just not even reasonable to do. 300-second exposure would not be the appropriate thing to do. So everything looks good and set up there. The options for configuring the light frames and the flat fields are shown when you click on each of the groups. So for the light frames, what I'm going to do is we will say that these are CFA images, which they are, and that changes this from a grayscale little icon to now a colorful icon. And we also, as you know, we need to change this because we discovered that information is not in the FITS header. So we need to call this RGGB so that it does its thing correctly. I'm going to exit out of here. I didn't yet make a little cosmetic correction template. You should always use cosmetic correction. One of the nice things is I can easily exit because I have the save frame groups on exit. So we will go to Process, Cosmetic Correction, and I'm in this particular case, without thinking about anything, I'm just going to use the auto detect method like that. And we will call this CC for cosmetic correction. Now we can go back into WBPP and continue. So we will choose CC, the template, and if we had more than one group, we would press the apply to all light frame. This should really be all light frame groups, but we only have one group, so you can press the button if you like, but it doesn't do anything. We are applying the cosmetic correction template. You can see it right there. We also need to go to the flats. Again, we need to tell it these are CFA images. It's going to still use what we have here as the pattern, so it understands the pattern information is coming from there. And I would recommend go ahead and use the separate CFA flat field scaling factors. This applies a scaling factor for each of the color channels. So that takes care of the calibration stuff in terms of the what we might call the pre-processing side of things. The other thing we might want to worry about, or at least consider, is the post-processing, the stuff that happens in addition to the initial calibration, and that's what all this stuff is here. It's also what's shown again in the post-calibration panel here. So I think what we want to do is just check things out. Most things are going to be fine. I am going to use what I typically use. It is my personal default, is that I'm going to use the PSF scale SNR as my subframe weighting method. I'm not going to worry about generating the drizzle data because I'm not planning on drizzling anything here. For the registration, everything by the automatic stuff here is just fine. Then local normalization, I am going to employ. This will do the proper matching between frames so that it will do the value rejection properly to get rid of any satellite trails and cosmic rays and other transient things that are going on between the frames. And then ultimately, once it's done that, you can do that as part of the image integration process. Now looking here within image integration, the combination method is going to be average. One of the things that I like to do is these are all the same exposure time, so I wouldn't mind doing the following. This isn't the way that this is actually designed by the developers to be used, but I don't see a problem in doing this. I'm going to say if any of the images have a weight that is calculated to be less than 0.4, that is, they're only 40% of the other images, whatever the best image is, then it's very likely not a very good image. And we just don't need to include it in the integration of the data. So that's something you can consider doing, is putting a minimum weight at some level, at some threshold, that below which you just don't even bother to use those particular frames. It's kind of like an automatic subframe selector kind of condition. The rejection algorithm, I can leave that as auto. It'll pick from one of the set. These are enough frames that I suspect it's going to use the generalized extreme studentized deviate, which is just fine. And I will go ahead and just leave the default settings there for the values. Now, all of these numbers and all of these things here, I explain in my tutorials at Atom Block Studios. I don't leave anything unexplained if it's possible at all. And that even includes these crazy, I mean, look at this, generalized extreme studentized deviate. What is that? I explain. So bear that in mind for those that are not members of my website. This is a good case, a good example of the kind of thing that I explain that you will generally not find explained anywhere else. So just consider that. One of the things that I didn't mention, but I should mention here concerning the image registration, I forgot to say that I am going to use the auto method here. I could pick one of these frames, but I don't think it matters. I'll just go ahead and let WBPP decide amongst all these frames which frame is the best based on the subframe weighting, and then it will align all the images accordingly. I don't expect there to be a problem. There will be a problem if I didn't have this in place here, which is the cosmetic correction. That could be a problem, and I have an entire video on that I would encourage you to check out if you have not seen it. Hot pixels can be the bane, especially of one-shot color camera CMOS type sensors. So consider that as well. So for post-processing then, now we can see everything is lit up here. We only have one kind of exposure, so we don't have to worry about really anything else. This is the total amount of time. I think the last thing that I'm going to do is just go ahead and set an output directory. And right there in place is a fine place to do it. I will select this folder, and we'll go ahead and tell it to go. So I should look at the diagnostics and make sure that there is no problem. There is no problem. It says that there are no bias frames, and that's true. There aren't any because we're matching darks for both the light frames and the flat field images. It tells us how much space is required in order to do this project, and that looks okay to me. So when we press the Run button here, it gives us that same thing, and then it starts. Now, one of the cool things about the latest and greatest version of WBPP is we get the execution monitor, which allows us to kind of watch as things unfold, make sure that it makes, it's working, it succeeds, but we can also see how much time it's going to take to do these operations. You can get a sense of that. It'll tell us how long it took to complete certain things, and then just based on the number of images, it'll be easy to see how much time it actually will take for us to complete the project. So I'll let this run and I'll come back as it continues to go, and we'll see what kind of output we get at the end. All right, so it appears to have done the job. You can see it took a little over 40 minutes to complete this particular set of data. The only thing that's worth mentioning here is it does say that one of the files it wasn't able to do the normalization on properly. I might accept that, especially if that same said file doesn't have a good weight or something like that. So we'll have to see if that has an effect. I doubt it does, so I'll just accept it. I haven't blinked through this data in this particular case. The exercise I'm trying to demonstrate here is really the setup, but it would be nice to see that it, of course, succeeds, and there's no other particular problem. So now let's go look at the output of what WBPP did so that we can see the end results and the folders and files that were outputted and everything like that. So we come back here, and now you can see that the number of folders have multiplied dramatically. And it follows the steps that were taken as far as the pipeline is concerned. And I'll just go in order here. So we used to have 4 folders, and now we have more. You'll see first there's this calibrated directory. And within the calibrated directory, we have calibrated flats, which are fine. So we expect to see 2 folders here. And then we have the calibrated light frames. When we look at the light frames, a couple of things. Number one is you'll see that all of the files have an _C. That indicates that they've been calibrated. I also notice that within those folders that we load the data from, many of these files have the same file name, even though they were taken at different nights. So WBPP here is doing a smart thing by adding an index where they are the same file name so that they actually become 2 distinctly different files when we put them all together, as is being done here in this folder. Just a small detail, but something that's nice. Next thing that happens is the cosmetized version, so that is the cosmetic correction. And again, looking at these light frames, you'll see that we have C and then followed by CC for cosmetic correction. So by looking at the file names, you can see the order of operations and how much has been done to a particular image. What follows that, as far as one-shot color camera information, is of course the debayering. So if I were to open up one of these frames, I would expect to see an actual color image. Let's see if that's true. Indeed, there is a color image here. So that's wonderful to see. We can see the colors. Now this is, I don't know if this is actually the linked or unlinked version here, because I was messing around with the screen transfer function earlier. Let's reset. Let's track and reset. Right. So if we do a linked version, okay, and then let's do the unlinked version, even better. Great. So the unlinked version of this image looks wonderful. So we can basically predict, I would hope, that the final combined result is going to look wonderful as well. And let's continue along those lines. If I opened up these registered images and blink them, we should find that they are all aligned with respect to one another. And of course, we've now added not only C, CC, the D is for debayered, and then the _R is for registered. So the final place that we want to look, we have the logs folder here. Now we don't see anything because I'm trying to open images, but if I put star.star, you can see that there is a log file, and this is verbose. This has everything that unfolded. So if there's a problem and we need to identify it, this is where we would want to look. So finally, we get to go here to the master directory. The master folder is where we're going to find a couple of things. But this is one of the things that actually confuses some people. So you already know we're going to find in here the master calibration files in terms of the two darks and the flat. But we also have a master light. This is actually the one that we're interested in. You can see up above there's something else. It has an RGB LN reference. This is not the output that you're interested in. This is an intermediate file. This is the file that was used to combine the set of some of the better images to create a local normalization reference. So this happens at the local normalization step. We can look at the image just for fun, but it's only a small subset of images put together to act as a reference for the local normalization process. This is not, and I repeat, not the final image. It's this one. This is the one that we're interested in opening. Oh, you can look at the other one, but this is the one we really want to see. We can look at the rejection results here. We see some star rejection, which could be because of seeing or looks like registration errors, tracking perhaps, who knows. At the low end, the rejection looks perfectly normal. We don't see very much of anything. And so this is, at the moment, the integrated result. It is not color corrected. And for purposes of WBPP, I'm not going to go any further. Here, of course, we would want to use DBE and then follow it up with photometric color calibration and go from there. Do all the kind of fun things that we need to do, all of the things that I demonstrate in my videos at atomblockstudios.com. This is the idea. But at least we can get to this point by using WBPP just by simply pressing that button after configuring everything and making sure that the input data is good. We do get good output data. And I hope that's what you see here is a strength of using the pipeline. And I hope you enjoyed actually watching this video to see something come out of it. Thanks.